Solve quadratic functions by factoring. Some techniques for factoring, we use the difference of squares. A squared minus b squared equals a plus b times a minus b. The perfect square trinomials, and they're called perfect square trinomials because on this side it's a perfect square and on this side it's a trinomial. We have one that has pluses all over, and we have one that has a minus, which shows right here. We factor so we could use the principle of zero products. A times b equals 0, and that's when we factor it. We end up with a equals 0 or b equals 0. The factoring technique, if it doesn't belong to these formulas, we use the FOIL method or refer to the FOIL method such that these two ends up being added because they are like terms. And we're going to be also using some problems under the topic square root property. So when you have x squared equals k and you apply the square root to both sides to get x by itself, don't forget to use plus minus on the right side. So we end up with x equals plus minus square root of k. Of course, if k is negative, we're going to have to use the square root of -1, which equals I, the imaginary number. I have 10 problems or 10 examples. Some of them they have more than one. As you could see, here's number 1. X squared minus 169 equals 0. To solve this, we could add 169 to both sides, and we end up with x to the second equals 169. We take the square root of both sides, and don't forget to add the plus minus. Left hand side becomes x, right hand side plus minus 13 for the square root of 169. So I have two answers. One of them is x1 equals 13 and x2 equals -13. Let's take another example. In this case, I have x squared plus 14 equals 50. So let's subtract 14 from both sides, and we end up with x to the second on the left. On the right side, 50 minus 14, which is 36. Applying the square root to both sides, we end up with x to the second under the square root equals square root of 36. One more time, don't forget the plus minus to be added. That will give me x equal plus minus 6. And that's the answer. That means we have two answers. One of them is called x1 equals 6, and the other one is -6. Here's another way to do the same problem. So we have x to the second minus, if you subtract 50 from both sides, minus 36 equals 0. Because we're used to factor and have 0 on the right side. And that will give me x to the second minus 6 to the second equals 0. Applying the difference between two squares, I get x plus 6 times x minus 6 equals 0. Now we could apply the principle of zero product. A times b equals 0 implies that a equals 0 or b equals 0. So this will give me two options. X plus 6 equals 0, or x minus 6 equals 0. Let's add 6 to both sides right here. And let's subtract 6 from both sides right here. That will give me x equals -6, just like this one. And that will give me x equals +6, like this one. So you could do it by having 0 on the right side and factor it and use the principle of zero products, or you could use the square root property and apply the square root to both sides, and don't forget the plus minus when you apply it. That is number 1. Let's go to number 2. X to the second equals -36. Applying the square root to both sides, which is the square root property, we have square root of x to the second equals square root of -36. And one more time, don't forget the plus minus. On the left I have x by itself. On the right side it's plus minus square root of -1 times square root of 36. And square root of -1 is I, which means we have plus minus I multiplied by 6. It's kind of hard to read it as plus minus I6. Instead we say it's plus minus 6i. So we have two answers. One of them is 6i and the other one is minus 6i. Let's take another one. X to the second plus 81 equals 0. Using the same method, let's have 81 on the other side by subtracting it. And now we have x to the second on the left by itself minus 81. Using the same concept, we have x to the second equals -81. We're going to apply the square root to both sides. And when we do that, we have to make sure that we add the plus minus. Left hand side becomes x. Right hand side, we have plus minus. Square root of 81 is 9. Square root of -1, just like the way we did it up here. That will give me I. So I do have 9i. Two answers. x1 equals 9i and x2 equals -9i. And that should do it. Let's take another example. X to the second plus x minus 30 equals 0. We could factor it now, and because I have three terms, so I'm going to go with two sets of parentheses. Let's undo this. Equals 0. Now we have x times x, and we have 30. We need to break down 30 to two factors such that they multiply to -30 and they add up to x. The way I do it is I go this way and I go this way, and I need those to add to positive 1x. This positive 1x is this right here. This right here is the positive 1x. Going inside, I have, let's give it a try. I have x minus 5 and x plus 6. So inside, the inner one from the word FOIL, we have 6x, and out I have -5 times x, which is -5x, and if you add them you get 1x as expected and as planned. With the principle of zero product, which shows down right here, we could apply it, and we see that that implies either x plus 6 equals 0 or x minus 5 equals 0. To finish the problem, we subtract 6 from both sides here, and we get x equal -6. And for the second one, we're gonna add 5 to both sides, and that will give me x equal +5. So I have two answers, -6 and 5. To do the second one, for more practice, let's move the 15 to the other side, and that will give me 10 x to the second plus 25x minus 15 equal 0. For factoring, we need the 0 to be on the right side, as you could see, so we could use the principle of zero product, and that is my 0. Now we could start by thinking about factoring it such that we keep in mind that when you go in for the inner part and for the outer part from the word foil, they both should add up to the middle number, and that is the 25x. The 25x is this right here. That's the middle one, after you move the 15 to the left and have a 0. To do it, let's give it a try. We have 10x and x, and for the 15 we could go 15 on the right side, but that's too much because 15 times 10x is like 150, which is extreme. So we need to rethink and keep the 25x in mind, because we don't want to end up with two big numbers such that it doesn't give me 25x. So after a few tries, you could try 3 here, 3 times 5, and let's test it. We have 5x inside, and outside we have 3 times 10x, which is 30x. To end up with 25x, I should think about a positive right here and a negative right here. So now I'm thinking about 30x, take away 5x, that will give me 25x. So the negative should be coming from the -5 multiplied by x, and the positive 30x should be coming from a positive 3 multiplied by 10x. With the principle of zero product, we could finish it by saying we have 10x minus 5 equals 0. Add 5 to both sides. I have 10x equals 5. Divide by 10, divide by 10. I get x equals 5 over 10, which is 1/2. The second part is x plus 3 equals 0. Subtract 3 from both sides. I get x equals -3. So we have two answers, and those answers are the 1/2 and the -3. That should do it for number 3. Let's go to number 4. Number 4, I have x to the second equals 8x. Now this time I do have 2 terms of the quadratic formula, not 3 terms. What do I mean by this? Usually we look at the quadratic equations. If it's ax to the second plus bx plus c equals 0, then we start factoring it. But in this problem, number 4, and I have 2 parts, or 2 types, a and b, it's only ax squared plus bx. There is no constant c. So let's move the 8x to the left by subtracting 8x from both sides. Once you do that, I do have 0 on the right side, and the left is x to the second minus 8x. 0 on the right. From x to the second minus 8x, we could factor x out, and I have x left for the first term minus 8. With the principle of zero product, that implies 2 things. Let's write or and come back. we have either x equals 0, that's my A, using the principle of zero products, or B is 0, which is x minus 8 equal 0. The first one is done. The second one, we need to add 8 to both sides, and that will give me x equal 8. So two answers, x equals 0 and x equals 8. That's the two answers. Let's call them x1 and x2. Let's try one more. This right here, we will be subtracting 2x from both sides. And now I have equal sign. 0 on the right. On the left, I have 45x to the second minus 5x. We could factor 5 and we could factor also x. So I'm going to take 5x outside as a common factor, the greatest common factor. Now inside I have 9x, because 9 times 5 is 45. And x times x will take me back to x squared. Minus 5x was taken out, so I have to put 1 as a placeholder. And now with the principle of zero product, one more time, we could say, therefore, we have two options, either or. Let's go with the first option. That's 5x equals 0. Second option, 9x minus 1 equals 0. Divide by 5, divide by 5. I get x equal 0. That's the first option. Let's call it x1. Second part, which is b equals 0, we will be adding 1 first to both sides, and that will cancel the 1, and we end up with 9x on the left, on the right side 1. Then we divide by 9, and that will give me x equal, let's call it x2, 1/9. So I have two answers, 0 and 1/9. Number 5. Number 5 is 81x to the second plus 36x equals -4. And for this problem, we will be using one of the formulas, and that's the perfect square trinomial, where everything is positive, as you can see. Positive everywhere. The way I like to write it down, instead of writing everything in one line, I like to have the three terms, because that's, once we move the -4 to the left, we will have three terms like this one. Then we go down to this form, which is the perfect square. So let's add 4 to both sides. Make sure when you add 4 on the left, you do it right. That's a 0. 81x to the second, 36x plus 4. Don't add them together and call it 40 or 40x, because they're not alike. 36x has an x in it, and 4 is just a constant, so we can't add them. We will write them this way, plus 36x plus 4. Now this right here is similar to this right here. So we're going to apply it this way. Here's 0. We're going to go down to this format with a plus sign and a square, just like this right here. Notice that a square comes down to a, and x square comes down to x, and this will follow by itself. So 4 will go down, 4 will go down to 2, and 81x to the second will go down to 9x. To double check that we're doing it right and we're following the same formula, let's do the following. I have a equals 9x and b equals 2. That's my a and that's my b. And the middle term is twice ab. So if it's x and a, you're going to multiply x and a and double it to get the middle term. So to multiply these two, and after that we double it, we end up with 9x and 2. 2 times 9x is 18x. 18x, when you multiply it by 2, when you double it, you get 36x. And that is the middle term, or the middle term right here. So we are following the right formula, and what we have, the trinomial, is actually of this format. This implies, with the principle of zero product, that 9x plus 2 equals 0. Then we could subtract 2 from both sides, and we end up on the right with negative 2. Negative 2. On the left side, we get 9x. Let's divide both sides by 9 to leave x alone. And the answer is x equal negative 2 over 9. That is it. Let's take more examples. Number 6. 64x to the second equals negative 49. In this case, I'm gonna use the square root property and have x to the second by itself, as you can see right here. To do that, I will be dividing both sides by 64. Divide by 64. So I have x to the second on the left, negative 49 over 64 on the right. Applying the square root to both sides, we'll have the following. We have the square root to cancel the square, and we have the square root right here. One more time, make sure that you add the plus minus. Left hand side is x by itself, right hand side is plus minus square root of negative 1, square root of 49 over square root of 64. This will give you I. This will give you 7, and this will give you 8. So what we have is x equal plus minus 7 over 8i. So we have two answers. x1 equals 7 over 8i, and x2 equals negative 7 over 8i. And that should do it for this problem. Next, number 7. Number 7 has 3 terms, and it follows the perfect square trinomial that is listed right here, but I like to see it as 3 terms to go down to the perfect square. So those are the 3 terms. We're going to go down to the perfect square. To do it, I will write equal 0, and I'll use one set of parentheses with a minus, because as you could see, we do have a minus right here, and that's the minus right here. And of course, if it follows exactly, that will be true. That will be a and b multiplied together and then double it. We'll check that in just a second. So we have 49 goes down to 7, just like a squared goes down to a, x squared goes down to x, 4x to the second goes down to 2x. Meaning, if this is a, that is a square. If this is, let's see, if this is b or a, let's call it a, that is a square. So whatever you have here, you square it up there, going backwards. So 2x times 2x will give me 4x squared. Let's double check that it does follow. When you multiply 2x times 7 and you double that amount, let's see if we get the middle part. The middle part is this right here, minus 28x. So going down right here, I have equal 7 times 2x is 14x. 14x times 2 is 28x. And of course, we have the minus already there. So we're looking at that twice a and x. So with the principle of zero product, let's go back and fix this. I'm missing the second because the second has to be there, as you could see. This second has to be there. So we have the second. With the principle of zero product, that implies that 2x minus 7 should equal to 0. Add 7 to both sides. I get 2x equals 7. Divide both sides by 2. I get x equal 7 over 2. And that should do it. Number 8. To apply the perfect square trinomial, as you could see, it has to be of this format, 3 terms. Then we'll move down to this form. So I need to move the negative 1 to the left and move the negative 1 to the left here to end up with 3 terms on one side. So to do so, we're going to add 1 to both sides. And when you add 1, make sure that on the left side, that's a 0 now. On the left side, we have 9 x to the second plus 6x plus 1. We don't add 6x and 1 together. Sometimes I see students, they add them and make it 7x or 7. They are not alike to be added, so you just need to make some room and add the one next to the 6x. Now, we are planning to use this format, so that will be coming down to one set of parentheses, all pluses, so we're going to use a plus, a square right here, and a 0. The 1 will go down to 1, and then 9x to the second will go down to 3x. Just think about it as whatever is here is square up here, and whatever is here is square up here. Sometimes I get students asking me, what about this one? Well, this one comes by itself following the format if we are using the perfect square trinomial. Now here is my 2 parts. We multiply them, then we double it. Here's my 2 parts. Multiply them, that's 3x times 1, which is 3x. Double that amount, and that is 6x, which is the middle term. So we should be fine. With the principle of zero product, we have the following. Therefore, we have 3x plus 1 equals 0. We could subtract 1 from both sides, and we end up with negative 1 on the right. On the left, 1 and negative 1 cancels, and we have 3x. Then we could divide by 3, and on the left we get x by itself. The right side is negative 1/3, and that is our answer for the first problem. Second problem, under number 8, we have the same concept, so we're gonna add 1, one more time. Since 1 is aligned with 8x, doesn't mean you could add them. We have the following. Let's give it some room right here put the 0 to the right, so we could have 3 terms on the left. I have 16x to the second plus 8x plus 1, not 9x or 9. Okay, now following the perfect square trinomial written on the right side, that should go down to a perfect square of this form, as you can see on the right side. 1 goes down to 1, and 16x to the second goes down to 4x. To double check that we are following the same formula, and it follows that trinomial that we have. We have x and a, multiply them, then double it. X and a, multiply them, that's 4x times 1, which is 4x. Double that amount times 2 will give me 8x. So we are on the safe side. Therefore, 4x plus 1 should equal to 0. That is 0 right here. Then we subtract 1 from both sides, and we get -1 on the right, 4x on the left, because 1 cancels with -1. Divide both sides by 4, divide by 4. On the left I get x by itself, on the right side -1/4, and that is my second answer, or my answer for the second part. It's like 2 parts for this problem. Number 9. We have x to the second plus 12 equals -13. Since we are having x to the second and some numbers, I need to write it of this type, so I could use a square root property, but we're going to end up with negative, so we need to keep this in mind. Square root of -1 is I, the imaginary number. So let's subtract 12 from both sides. The reason is we need to have x to the second on the left by itself, as you could see right here. X to the second by itself. So we have x to the second on the left. Right side -13 and -12 is -25, and this cancels. So we have x to the second equals -25. I moved it a little bit to the right so I could add the square root. And not only that, add the plus minus as needed. So we need the plus minus right here to show up. Left hand side is x by itself. Right hand side is actually a plus and minus square root of -1 times 25, which is plus minus square root of -1 times square root of 25. That will give me I, and that will give me a 5, but we don't want to write it as plus minus I5, so we write it instead as x equals plus minus 5i. We'll push the I to the right side. So if you want to write them as 2 x's, we have x1 equals 5i, and we have x2 equals minus 5i. And that's the answer for number 9. Last problem. This one here is not following the perfect square trinomials or difference between two squares or the square root property. So we need just to factor it using the in and out, the inner terms, the outer terms, the first term, and the last terms. To do that, we need everything on the left first. So this has to move to the left. This has to move to the left. And that's how we factor. We have a 0 on the right side. 27x to the second. By moving 48x to the left, it will show up as minus 48x, and let's put the 5 here. So instead of writing plus 5 minus 48x, I wrote it in descending order so we could start factoring. When you factor this, it takes longer because the leading term does not have 1 as a leading coefficient. It has a 27. 27 will give me more options to factor and takes longer to find the right factors that will make or add up to the midterm, which is negative 48x. We need to stay focused on getting this number right here when we start factoring. Let me show you how. So we have two sets of parentheses, and we need the in and the out to add up after we factor correctly. I need to add up to minus 48x. So it's like we're thinking about two things at the same time, and that's what makes it a little bit hard for some students. So now let's focus on getting this ready. If you start with 27x times 1x, that's going to be a little bit extreme, because anything I'll try after that is not going to make a 48. So if I put the 5 here and a 1 here, 5 times 27 for the outer ones, that's a big number. There's no way. And if I switch it and I write 5 here and 1, I get 5x in the middle and I get 27x out, but that's not gonna give me a 48. That's gonna give me like what, 27 and 5, like 32. So let's think about factoring the 27 and 5x in a different way. Let's cancel this and cancel this, and let's go back. So we have to think differently. I'm gonna not waste your time. I showed you the idea of like 27 is not gonna work, so let's go with the right numbers. 3x and 3 times 9 will give me 27x to the second. That's another option. Now I know, before I move on, that I need to end up with a positive 5. That's when you multiply the last ones, you should get positive 5. But since I'm thinking about a negative in the middle, there is no way I could go positive 5 times positive 1 or positive 1 times positive 5. So it has to be both negative. As you can see, factoring takes a lot of practice. It doesn't come in just like few types of problems. It takes a lot of practice. So I have now two options. Either I go 5 here and 1 here, or the other way around. But how do you find which way? Maybe 5, 1 and here and 1 here. As I'm doing it, as I'm thinking about where the 5 should go, because 5 could only be factored 5 and 1, not too many options like the 27. I need to think about the 48x. In this case, I think it's going to work out, so let's give it a try. The inner one is minus 5 times 9x, which is minus 45x. The outer ones, as it shows on the notes on the right side, multiplying 3x times minus 1 or negative 1, that will give me negative 3x. And if you add the minus 45x and the minus 3x, you get the minus 48x as expected. And that should do it. But we're not done with the problem, because we are solving. To solve it with the principle of zero product, a times b equals 0, that means this is my a and this is my b. So either a is 0 or b is 0. So let's do that on the side. Therefore, we have 3x minus 5 equals 0, or 9x minus 1 equals 0. Solving the first one, we could move the 5 to the other side. And now we have 3x equals 5. Divide both sides by 3. I get x equals 5 over 3. That is my first answer. And let's call it x1. For the second part, let's move the -1 to the other side by adding 1 to both sides, or in short we say move it and change its sign. So we have 9x equals 1. Dividing both sides by 9 to leave x alone, I have x equal 1 over 9. Let's call that x2. And now we have two answers. x1 equals 5 over 3 and x2 equals 1 over 9. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.